Hello, this is Alexander McGurk doing the screencast for the repeat of CA1 in Data Structures, Semester 2, Year 2 in the Games course. This CA was to create an array with multiple different functions in it. I'm first going to run through the actual piece itself, and then I'll go through the code and explain stuff. So to start off, I just filled the array with some simple integers, 10 no digits there. Now the first function, is a resize function. I set this up to have an error, which I'll explain when we're looking at the code, if they try to downsize. So as you can see there, error size entered is less than the current size, loss of data imminent. And there's the same one as before, just to show that nothing's been changed. A resize that's higher than the original input, in this case 13, adds on the new spaces, fills them with garbage data. Then there's a count, just to tell you how many elements are in an array and how many spaces are in the array. So this success, as you can see, counted all the elements, and it states that there's 10 elements in the array of size 13. So that's all correct. An insert method was to insert an element into the array and keep its order. So first I inserted 145 here, which is higher than any of them, so it will go at the end of the code, which you can see there. It's been pointed to number 10. And then a second insert, just to show it's the ordering system, insert 78, which is higher than the originals but lower than what I just put in. It comes up between the two of them, so you see it's after taking the spot of 10 and pushing 145 down to 11. Then there is a remove function to remove the last element in an array, whichever one is the final one at the time. So you see 145 is the last there, it's been removed here. Then there's a remove specified element from array if you want to specifically choose one element to get rid of. In this case it was number 4, so as you can see here the element number 4 is gone now and everything else has been pushed up to keep its order. The search methods, there are two forms of the search method, linear method and binary method, which I'll go into detail when we're looking at the code. There was also some timing pieces I'll explain later. But as you can see here, I did two versions of each search, a valid one and an invalid one, just to see how they'd work. Searching for number 6, linear method for style, given a success, it's telling you where it is. And searching for an invalid number doesn't bring up anything. Then searching for the same number, for the same style in the binary method. Searching for number 5 is to find it's number 4. And again, an invalid search with the binary will just bring up an error message saying a specified element couldn't be found. Then there is a write function which writes whatever's in the array to an external file, which you can see over here in the write file. It comes up as binary text. So if we just delete this and run this again, there you go, you can see it's been put back in, so the write is working. And after the write method, then we had a clear all, just to remove all the elements. In this case I put them to 0 because I was trying to get them into a garbage data form like these, but I can't seem to find a correct method of doing so. And finally a read, which I couldn't do the first time around, but I got fixed up. So I have a text file here of different data, 20 to 33, and this read external file, you can see we'll read the mail in such, and it will give you a little piece saying that each element is successfully added. The first thing the read does is clear everything, by the way, and you can see that this will also work for resizing elements. If we add in a few more and we run this again, So as you can see, it's adding on new elements, and then when it ran out of space at the 13th spot, or 14th spot, sorry, it would resize, and then it would keep resizing until it had enough. So you see there, it's been resized all the way to 17 there, or well 18 if you include 0. Okay, so I'll just run you through the actual code now. The main, I didn't have a menu for this, so I just set it up as detailed as I could here, with the individual tests and comments and such. All that's in the main though is calling the different functions and then displaying them out to the screen. I used the int size, timer pieces, and total. These are all for time. The only things to include was an IO stream for the cout, cin, and L that I'm using, and then the connections to an array header and a time header. I also had a piece in here for memory leaks, so there's that, and that piece as well. So with the timing functions, I'm not 100% sure if this is the correct ones, but I got this code from Stack Overflow for again time in milliseconds. So there's all this work now, and then the method I found to call in this was to create two timers and call one of them before calling the function, then call the second one straight after that function, and then just take the first one away from the second one, and whichever I'd have there would be the timing difference. So if you look at the two search methods this we used on, the linear search took 5 milliseconds to find, whereas the binary search took 2 milliseconds. So it's obvious which one of them is much faster, that the binary search is a much more effective method of searching for stuff. Other than that, it's just typing and stuff. So we'll go to the array file. Okay, so the array header, first it was set up as a template, so you can use other forms of inputs, ints, strings, and all such if you wanted. There's just a few includes I needed for the different stuff. I needed the cmath for the binary search here, and the studio for the file input and output, so I could read and write and such. Using cout, and L, fread, and then just the general namespace. So the first thing we have is some private and public variables with the num elements, grow size, and em size set up in private here, and then an em array set up as a data type pointer. There's the constructor, which creates a new array and takes in a size, which you can see from up here, array int elements, and the size added in. Then this just sets up a new data type of that piece size and sets em size to that size as well. Destructor set up for the end, to delete the array at the end of the code automatically. It can be called prematurely, but it's not recommended to do so. And this just checks if the array is still there and deletes it and sets all pointers and such to 0. The fill I used just to fill it with some basic integers to start off with. Nothing special there, just a little for loop to do that. We have to set an overloaded operator so we can use the arrays properly, so that's just this piece of text here. Now the resizing. Resize is to resize the array to user specified size. This is done by creating a new array, passing the contents of the old array into it, and then deleting the old array. This takes in size to set new array to, note set up to reject downsizing. I chose to personally do this, and I'll explain now why. First we have in here, like this says, you set up a new array equal to the original, to the same type of data type. If the new array comes up as 0, then you just have a little output message saying that it failed to initiate. Then there's the checking to make sure the new size is greater than the original. This piece here, if p size is greater than or equal to em size. Now I set this up so that if it's greater than the size, then it will continue on with this null, and here you can see else. If it's not, it will just give out an error message. I know how you would do it the other way around. If it's just the reverse function of this put into here. You just change, instead of emphasize equal p size, the other way around and such, and it will go in here, and then the same idea that you fill in the array null. I just chose to do this because in my mind it seems a bit hazardous to have a resize function that you could downsize in, because say for example if you had an array of a few thousand employee information for a company and you're resizing it, if you miss so much as one integer when you're typing in, there's a big difference between 1000 and 100, so you could end up potentially losing loads of information just because of a typo error. You could, I suppose, alternatively set up just an extra message here saying, like a warning message saying what you're going to do and do you want to continue or not. No, if I had more time I'd probably do that myself. To resize, here you set the grow size to p size, and like I said, if it was the other way around you'd set it down size anyway. Then a small for loop set up here to fill the new array with all the contents of the old array. You set m size to be the new p size, and then you delete the old array and set it to new array. Then just a little output message saying that it's been successfully resized. So like I said in the comments, that's just making a new array, putting everything from the old array into the new one, and then deleting the old one and setting the new one as your proper official one. Then regardless of whether it does an if or an else, you have to make sure that you delete the new array, otherwise you'll get a memory leak. A simple count function to say just how many elements there are and all this, just saying how many elements are in the array and what the size of the array is. Next is a push function. This is to fill a space in the array if statement for resizing the array if necessary. Set a boolean to sort through before putting in place, and takes in the item to be inserted. So here you take in whichever item is being pushed in. You set the index and set a boolean location to false. Sorry. The if here set up for the array to go through the array of each index piece to make sure that it's greater than -1. If so, resize it to +1 and such. Now here you have to make sure that you search using num elements, as that's the amount of elements there are, as opposed to the size, which is the amount of spaces, because you're looking for the elements that are in the array, not how many spaces there are of the array. So this is just a if section set up to continuously go through all the elements until and checking them to see if they're larger or not than whichever the one being passed into is. When it eventually comes around that the one that's being passed in is greater than, it'll be set up to true. Then a simple for loop here to rewrite them all so that they all set into the right order and put them into the right placements. Once that's finished, then you put in marray index equals p item, so that's inserting the actual new one that's just been put in, and you increase num elements just to include that there's a new element, and then another output message. The pop function is very simple to remove the last element in the array. Simply, I just called the remove function, which is the next one you'll see, putting in num elements -1, and then just decrement num elements by 1. The remove function here, this is to take out an element by its index position and keep the order of the array, so it takes in whatever the element is you want to remove. It does a for loop to find that element. Then when it does, it deletes it and it pushes everything back from that position, so it will continue through. For example, the one we used was remove the element 4. So that gets the position of 4, it removes it, and it takes whatever's in front of 4 and pushes it backwards, and does that continuously for the rest of for the full array. We'll continue this in the second video.